This question is design HashSet. So you're giving a class, my hash set, and then you want to implement add, contain, and remove. And again, the set for the time needs to be constant. So like the regular hash set, if you add, if you remove, if you contain, the remove contains, and then this all consider all of one, right? In the normal regular library. So we want to perform the same. Time is going to be all of one. Base is going to be all of n. So yeah, this will be the optimized solution. And back to the question. So again, let's just dive into the example. Add. So add one, add two, and then you contain this one in the set. It is going to be returned true, right? And then if it contains 3, which is not, so you return false. And then you add content and then so on, right? So pretty straightforward. So what we can do is we look at the key, the size for the key in the hash set, and then it's only return true or false, right? So true or false. And then what we can do is what? We can create a Boolean array with this size of the the Boolean array, and then we can say equal to true when you add, and then remove when it's equal to false, and then contain is checking does the current value is true or false. So that will be the first solution. It's pretty tricky. So let's say Boolean, the Boolean array, and then I would say visit, and again I'm gonna have a size. So the size is going to be 1e6 plus 1. Okay. So I mean, I would do the plus 1 later, but size is going to be 10 to the 6, right? And then you want to include in the 0. So uh, visit equal to Boolean and then size plus 1, something like this, right? And add is pretty straightforward. You set the current key equal to true. You set the current key equal to false when you remove. And for the contain, just checking the current value. So it should be good. Oh, so Boolean array. Oh, new. Forgot the new. And 1e needs to contain to the integer. Yeah, so this will be the solution for the first one. And the second one is using the OOP. So OOP, this is going to be a little bit tricky, but let me go through it. So I'm not going to create this size 1e6. I'm not going to create this space. I'm going to select a random prime number. It has to be prime, so it's not going to be odd, but it's prime. The prime is going to be you can only divide by this number or 1, right? And then imagine I only have this length of the size for the hash set. So imagine this is less than 1e6. So something is going to be using the same location, right? And then in the same location is considered the same key, but they actually linking to different values. So it's going to be at the same key, but there's a array list or linked list. Doesn't matter. Like, uh, just think about this. So, it's the algorithm, right? So same key, and then traversing the list when they have the same key, and then return true if you found it, return false if you didn't, and then remove is pretty straightforward. You comes to the same key and then remove the current node or current the current integer, right? So so let's do this. So class, and it's going to be bucket and linked list, and then since I only need to store the integer, so it's going to be integer for linked list. and then public bucket, and then initialize the linked list. So I can add, right? I can add, I can remove, I can find. So what does bucket represent? Bucket represent at the same key you want to traverse. The number of the node that have the same key. So it's going to be bucket array bucket in the set, right? And the size is going to be prime number. So prime number is 769. And then I will declare the size of the bucket size BUC. And then for every single index, I need to initialize size I plus plus, and then bucket that I equal to new bucket. Okay, so this is my main class. I construct everything, and then back to here. So what do I need to do here? I will need to do the add. So add based on the key. So key is going to be represent what is the value, right, in the current linked list. So in this case, so think about this. In this case, I already know my key. So sorry, I already know my hash key, and this key is represent the current list value, right? So imagine this is 6, and then you have 1, 3, 10, 9, 12, 6, and then you will traverse. Is this current value 6? No. Go on next 3, 10, 9, 12, 6, and so on, right? So if you find out 6, then you return true. Actually, this is add, right? So add is just adding to the last one. But if you remove, you want to still doing the same thing. You want to traverse, and then you want to add. And then, sorry, if you want to remove, you just traverse, found it, and then you remove. And then content is just traverse and found it, and return true or false. So yeah, so I will have a remove. I will have the content. It has to be Boolean. So we can do the XX, and then it has to be find the value using the key just in case. So it's pretty straightforward. So list dot contains key. I know this is all of n for the linked list, but since they have the same, so since they're showing the same the hash key, and then traversing this linked list, I mean it should be constant, not a big problem. So add, I want to find out that if the current integer is in the list. So since we are adding the integer into the linked list, so it should be just say if this does not contains a key. I said list dot add the key. But if you want to add a key, you want to add the first one at the first position. So again, we don't want to. What happened here? So add the first one. So which means it's going to be all of one. If you just say add, this will add to the last one in the linked list, and we need to traverse all of the linked list to the last one and add a key, which is all of n, right? So if you add the first one, it's going to be all of one, and then contains definitely all of n. So, but again, like this has to be we add in the integer, not the tree node, not the list node, or something like this. I mean, this can be optimized, but not this moment. So remove. You want to know, you can remove. So what you can do is this: find out the current index in the linked list, and then remove the index right away. So you will still need to use the index of. So index, remove index equal to list dot index of based on the key. And then if the remove index does not equal to -1, I would just, so does not equal to -1 mean it doesn't does found, right? So if you're not able to found, it's equal to -1. So you will say list dot remove the remove index. So yeah, this will be everything for the bucket, and then so we have the size for the prime number, and then we want to know the hash key, right? So public int get hash take as int key, and then it has a return key mod by the size. So every single method just say hash key equal to get hash key. Like you need this, like literally, and then okay, cool. And then basically, like at a current index, add a current key into the linked list, remove the key into the linked list, and then return if the key is in the linked list. So that has to be bucket based on the hash key, and then this will return the linked list, right? And then you say dot add the key, and then it's going to be the same or similar, but not add but remove, right? We have the remove. And we have exist, right? So right here exists, and it has to return a boolean. So this will be the solution. Come on. So bucket list integer. Oh, linked list. Okay. Yeah. All right. Again, trying to optimize this, but again, the size is all of 769. I mean, I don't know. I mean, it's considered prime number, right? Oh, or you can change another one, but it has to be less than 10 to the 6. And then you get a hash key, you add it into the linked list, remove, send idea, hash key, remove, content, hash key, return if found it or not. And this will be your helper function, helper class. So this will be a solution. All right, see you.